To continue the topic of understanding the interest rate, I want to introduce the yield to maturity. Yield to maturity is actually one type of the interest rate that it is derived from the equation of present value of cash flows that is received from a debt instrument with its value today. So it means that the kind of the interest rate that equates two things. On one side is the present value of the cash flows, on the other side is today value. So this interest rate that equates these two things together is called yield to maturity. In today's topic, we want to calculate yield to maturity for four types of the instrument. The first two types is simple loan and the fixed payment loan. Simple loan is very similar to whatever we have discussed about the present value or the discount value of the future. So to understand more about it, let's try one example. For example, let's say that Peter borrows $100 from his sister, and the sister expects him to return $110 in a year time. So it means that in next year, Peter has to return 110, the amount that he borrows today from his sister, and the amount is 100. So we want to calculate that how much is the yield to maturity. I have written the explanation of the yield to maturity here, so we just follow the explanation. Explanation is saying that the interest rate that equates. So as soon as I see equates, so it means that I have to put one equal here, because it is equate means that something which is putting two things equal to each other. The first part is the present value of cash flows. For the simple loan, we know that means that the cash flows is only for once. It means that whatever amount you borrow from somebody, you have to return it only once, all at one time at the period that you have promised. For example, let's say that the period in this example is 1 year, so Peter has to return this whole amount of 110 at once next year. So that's why the present value of the cash flow, we know that whenever we are talking about the present value, we have to put 1 plus I in the denominator, and here is the future value, right? So future value here is the amount that Peter has to return or has to receive. Which one? Of course, has to return. So the amount is 110. So the present value of the amount that Peter has to return. So equal to what? It's saying that equates the present value of cash flows, which is here. So this is the present value of the cash flows with its value today. What is the value today? The value today is the amount that Peter is receiving from his sister. So the amount that he is receiving is 100. So this is the formula of the yield to maturity. This I here is actually yield to maturity. So if we want to calculate, it is very simple. So you can see that I open this equation. For example, 100 multiplied by 1 plus I is equal to 110. Isn't it similar to whatever example we previously discussed about the present value, you remember? So then we can open it even somehow. It will be 100 plus 100I, which is equal to 110, and 100I, it will be equal to 10, and therefore I is equal to 10%. So this I here, since we got this I from this equation, which is the equation of present value of the cash flows with its today value, so that's why this interest rate is called yield to maturity. In another words, we can say that yield to maturity for the simple loans is exactly similar to the concept of the interest rate that we have been discussing before. So now we move to the next debt instrument, which is the fixed payment loan, and we want to know that how to calculate the yield to maturity for this instrument, debt instrument. This time we imagine that, first of all, what is the difference between fixed payment loan and the simple loan? As I discussed, for the simple loan, no matter that how much is the period, it can be 1 year, it can be 2 years, or it can be, the N can be years. But the only point is that we add the whole sum we return all together. But for fixed payment loan, it means that we put some periods and we have to pay a fixed amount within each period. Normally the period is annually. That, for example, you apply for a loan of 25 years and then each year, yearly you have to pay the installment, or sometimes maybe monthly you have to pay the installment. So for the simple loan, the cash flows, the present value of cash flows is only once, because at once we return the whole amount. For the fixed payment loan, since we return in different intervals and this returning is a frequent procedure, so that's why we have different cash flows. We don't have one cash flow anymore. So here again, we want to follow exactly the interpretation or the definition of yield to maturity. So it means that again, I need to put one equal here. So on one side, it has to be the present value of cash flows. This time, I have different cash flows, right, based on the amount of the time that we have. For example, maybe it is 1 year, or it can be 2 years, or it can be 3 years, or it can be n years. So based on the different years, I have different cash flows. So I put the present value of fixed payment equal to what? It's today value. How much is the today value? Today value is the amount that we got as a loan today. So today we receive 1,000 is this in this example. And then how much is the fixed payment? The cash flows are 126 in this example. So that's why I put here, for example, fixed payment. And then I have to calculate the present value of the fixed payment. For first year is this. For the second year is again fixed payment over 1 plus I for the second year. And until n years, that it is fixed payment and 1 plus I for the year n. So this fixed payment is in this example is 126. I is the yield to maturity here that we are looking to calculate. So n in this example is equal to 25. Again, calculating this formula based on the normal calculator is not easy, and we need the financial calculator. The usage of financial calculator will be taught during the lecture class, and I'm sure that now you can use your financial calculator and you can tell me that how much will be the I. I'll get back to you again.